All right, well, now we're gonna do worksheet 6A. This was a worksheet that was given out in the in-person classes. So I am gonna record the solution for this and hopefully you will understand. If you don't understand, please let me know. I'm happy to help. All right, so it says the tip of a one-link robot is located at theta equals 0 at time t equals 0, as shown in this figure. It takes 4 seconds for the robot to move from 0 to 2 pi. So that's going to be important, okay? And we have L equals 8 inches. And we want to plot the X and Y components as a function of time. Amplitude, frequency, period, phase shift, and time shift. Okay, so let's first talk about what all the pieces are. And then we will graph it. Or we could do it the other way. It doesn't really matter. But let's just kind of write down what everything is. So we have amplitude. And amplitude is going to be that 8 inches, which is the length of that arm, right? And then we have, okay, so that's amplitude. Frequency, let's wait for frequency because we can find the period. So the period is going to be so it's going from 0 to 2 pi. So we want to find our new period, right? So it's 2 pi over, and it takes 4 seconds for the robot arm to move that far, right? So that means it's going to be over, hold on. Okay, it's going to be over omega. We're going to use omega because now we're talking about things from our book. And we know the new period, right? The new period is 4 because it's taken 4 seconds. And we're plotting this as t. So the period, the new period, is going to equal 4, which tells me what. So we found omega. So we found the period. The frequency is going to be 1 over p, which is equal to 1/4. Okay. The phase angle, the phase angle is the shift. So if we're shifting it right or left, then we have a phase angle that is not 0. But here, the phase angle would be considered 0 because there's no horizontal shift. And the time shift, so the time shift is going to equal, it's going to equal the, here, let me write the original, let's just write the equation out. So we have y equals, and I believe this is a sine functions because it says at theta equals 0, is located at 0 at time 0. So at time 0, everything's 0. So that means we have a sine graph. Sorry. Sine. Our amplitude is 8. That goes at the beginning. Then we have omega t plus, let's see what the, oops. I don't know why I did that. Okay, sorry about that. Okay, sorry, plus theta. Okay, well, theta is starting at 0. So that makes this 8 sine of omega t so our time shift is always, and I want to show you a different way to do it, but for right now, we'll just call it our theta over omega, okay? And since theta is 0, our time shift is 0, okay? So we found all of these things. Now, basically, the last thing we want to do is graph it. So, we didn't find B. We didn't find omega. I'm sorry. But we do know, let me do that. So we know that P nu is equal to 2 pi over omega. And we know P nu equals 4. So 4 is equal to 2 pi over omega, which means omega is equal to 2 pi over 4, which is equal to pi over 2. And that is my omega. So now my function is pi over 2t. Okay, now I think we got everything. Function of time, yes. So now we're going to graph it. And I know that, let's see, do I want to graph it that way? I think we could do this easily. Since we know one period is 4, we can just say this is 1, 2, 3, 4. We know it's going to 8 and down to -8. And we know it's a sine, so that means it's starting at 0. At the first, this would normally be pi over 4. So this is our first value, sine of pi, I'm sorry, pi over 2. This would be pi over 2. At pi over 2, our sine is 1, so we go here to 8. This would be pi over, this would just be pi. So this is 0. Actually, I probably should show you how that all works. So let me do that before I. So normally this would be, let's see if I can do it like this, make it not as bright. Yeah, I think this will work. So this is pi over 2. This is pi. This is 3 pi over 2. And this would be 2 pi, right? But we know that our let's see what we know that made us figure out. So we know that our new period is 4, which what we did is we divided everything by hold on a second. So we have 2 pi over omega, and we didn't divide anything. We were told that our period is 4 seconds. So after I have that, then I found what omega is. So omega is pi over 2, which means that I would have had to divide each one of these by pi over 2. Divide by pi over 2. Divide by pi over 2. And divide by pi over 2. So there's my 1. This is 2. This is 3. And this is 4. Pi's cancel with pi's. 2 cancels with 2. Pi cancels with pi. This becomes times 2 here, and so on. I think you guys can do the algebra. Yes. Okay, now I think I've explained what I need to, and then let's just draw a graph in. So we go up there, go down to here, down to here, and up to here. And that is 1 period. Did I get everything? Let's see. The tip of a 1-link robot is located at theta equals 0 at time t equals 0 seconds. It takes 4 seconds, that's our period, for the robot to move through one whole period, 0 to 2 pi. If L equals 8, that's our amplitude. Plot the x and y components as a function of time. And then we found our amplitude, our frequency, our period, our phase angle, and our time shift. So I think we've completed problem number 1. Let's move on to problem number 2. So this is our, right here, this is the general form of, for this one, it would be a sine. If you had a cosine there, then it wouldn't change anything except basically it just shifts the same graph to a different position, right? And here it's talking about what each thing means. A is the amplitude, omega is the angular frequency, and theta is the phase shift. Now, also, the time shift, which is something that we haven't gotten from here. So remember, if you watch the video, the general videos on graphing, I said if you have a shifted form, well, and this is a shift, this plus theta is a shift. What you really want to do is factor out the omega. So we would have sine of, and I'm going to factor out omega. That becomes t. When I factor omega out, basically I divide both of these things by omega. So this would be t plus theta over omega. Okay? And as I've said before, this is our amplitude. This is our angular frequency, as it says, angular frequency. And now, instead of it being called our phase angle, this is called our time shift, which is basically our horizontal shift. So if you want to know how much you're going to shift something to the right or to the left, you would look at that number after you factor out that omega. Okay. All right. So now let's do this problem. Hold on. Okay. So consider a cart of mass m moving on frictionless rollers as shown here. They're just saying frictionless because otherwise we'd have to add something else in. The mass is attached to the end of a spring of stiffness K. So harmonic motion of a spring mass system. Suppose that the position of the mass V of t is given by this equation. Now we're getting to a different equation. I told you what each thing means, but now we're going to talk about it a little differently. So suppose that this is our equation. Determine the amplitude angular frequency, period, phase angle, and time shift. Okay. And we have our hint there. So A, our amplitude here is 2. That's our amplitude. I'll change colors for everything out of that. Our angular frequency, which is our omega, is equal to 6 pi. Our period is equal to 2 pi over, so remember, I have to divide by our omega over 6 pi. So our period is 1/3. Our phase angle, so that's our theta, is our phase angle. And I didn't change color, I said I would. Our phase angle, theta, is pi over 2. And our time shift, let me get another color. What color do we want to use here? So I use red, blue. This was all supposed to be in green. Actually, let me just change it to green. So our phase angle is theta, which equals, so we'll do that. And then let me get one more color. Let me choose black. And our time shift is equal to theta over omega, which is pi over 2 over 6 pi. I'm going to simplify this fraction. However you do it, you're going to get the same thing as I am. Basically, this is 2 times 6 pi. Pi's cancel, and I get 1/12. So 1/12 is my time shift. Okay. Now, it says for B, let me line there, and do B. Okay, so B says find X of 2 seconds. Which is, this is X of T, so basically at T equals 2. And I have the whole equation, so I can just say X of 2 is equal to 2 times the sine of 2 times, here, I'll write it out, 6 pi times 2 plus pi over 2. So this is 2 times the sine of 12 pi plus pi over 2. Well, if you remember coterminal angles, if I have 12 pi plus something, so 12 pi plus pi over 2, remember that on my unit circle, if I start here and I go around the circle one time, I have 2 pi. So every 2 pi, I'm going around the circle a full cycle. So 12 pi really is 6 times around the circle, but I'll end up back at 0. So I don't really care. I can rewrite this as the sine of pi over 2, because the 12 pi just kind of circles back around over and over again. And then the last piece makes it go to pi over 2. And the sine of pi over 2 is equal to 1. So this ends up equaling 2 times 1, which equals 2. So that is how you do B, or number 2. Number 3. All right. So the typical one-link robot is located at minus pi over 4 radians at time t equals 0. Oh, this is a little different. So let's make sure we remember. Theta equals minus pi over 2 at t equals 0. The robot is rotating at an angular frequency of 4 pi radians per second. And we know L equals 7.5 centimeters. So we want to plot the y component as a function of time. Well, first, let's make our equation. So I have y equals, and the amplitude is the length of that robot arm, right? So that's our A, 7.5. Is it telling me? So at t equals 0, we're at minus pi over 4. So this is going to be the sine of omega, which is our angular frequency, is 4 pi t. And then it's lagging minus pi over 4, or minus pi over 4. Okay. And I think we have everything now we need to have it into that right form. Yes. So let's figure out some things. Let's first figure out what our period is. So our period is going to equal 2 pi over, let me write here, omega equals 4 pi. And so this is going to be over omega, which is equal to 2 pi over 4 pi, which equals 1/2. So our period is 1/2. Okay. We also need to know our time shift. And I'm not sure which way you guys would prefer it. So I'm going to just say, this is what I called shifted form. If you watch the 3rd video that's there, where I just factor out of 4 pi, and then I get t minus pi over 4 over 4 pi, right? Because I factored out of 4 pi. So I get y equals 7.5 sine of 4 pi times t minus, pi's are going to cancel, so it's going to be 1/16. Okay, which is now I actually have all the information I need, even though they're not asking for it. But my time shift, once I factor that 4 pi out, this is my time shift right here. So my time shift is 1/16. I have my omega, I have my amplitude, which is equal to 7.5 centimeters. And I have my period. I think I have everything I need. So let's graph this. Let's see, what do I want to do here? So I know my period. Let's go back to my period. My period is 1/2. Okay, so let's do it. I think this might be the best way. So my period is 1/2. And remember, we have usually 4 markings till we get to the period, right? We have like the pi over 2, pi, 3 pi over 2, and 2 pi. So let's call that that. So halfway between 0 and pi over 2 is, I'm sorry, 1 over 2 is 1 over 4. Basically what I'm doing is I'm dividing this 1/2. So I have 1/2 and I'm going to divide it into 4 pieces, right? Because I have 4 tick marks, which is equal to 1/8. So that means this is 1/8. This is 2/8, this is 3/8, and this is 4/8, which is the same as 1/2. Okay. Did it say how many? Okay, it doesn't. So we'll just do 1 period. Okay. And I know that this is 7.5. And this would be negative 7.5. So if I had my just graph without a shift, I would just start at 0 and I would go to 1/2. But I have this shift. So what I'm going to do, and since it's 1/16, I'm going to divide each one of these in half, because I need to know where 1/16 is. So this is 1/16, 2/16, 3/16, 4/16, 5/16, 6/16, and 7/16. So also, if I'm shifting it, this is 8/16, so this would be 9/16. Now, this is really the end of my graph. At this point is my end. At this point is my start, because this is a horizontal shift to the right. Okay, so normally I would have my 0 at 0, but I'm shifting it over to 1/16. I would have my maximum height at 1/8, but I'm going to shift it 1/16. I would have my 0 at 1/4, but I'm going to shift it 1/16. I would have my negative 7.5 at 3/8, but I'm going to shift it 1/16. And I'll be back to 0 normally at 1/2. So I'm going to shift that there. And this is my graph, my shifted graph. And then this would actually do that. And that is, I believe, everything I need for this problem. Yep. So I found everything. I graphed 1 cycle. We could graph more, but it's fine. 1 cycle will do. And that's the end of this video. So thank you for watching.